So before we start today, take a moment to solve the equation for a, solve for x. Stop the video and do that. So you should have gotten x equals 5. Now we're going to solve this same equation again one more time, but this time we're not going to actually go through and do any of the arithmetic. We're just going to go through the steps that we would need to solve it. So the first thing that we would do to find x is we subtract 7 from both sides. Now these guys, we're going to go and cancel that out because 7 minus 7 is 0, and then I'm going to get, instead of writing 4x equals 20 here, I'm just going to write 4x equals the process I would do. I would do 27 minus 7. You guys all agree 27 minus 7 is 20, right? So we're just going to write the math right now. Then we're going to isolate x, so since it's 4 times x, we divide everything by 4. Divide everything by 4. And so what I'm going to do now is I'm just going to write that x is equal to, and I'm going to write the expression that x is equal to, which is 27 minus 7 over 4. Now if you take a look at that, what we've done is the same exact process. If I were to take this expression right here and follow the order of operations, 27 minus 7 is 20, and 20 divided by 4 is 5. So you guys can agree that these two answers are basically the same thing. The reason I had you do that is, what if you get a problem like letter C, where now instead of having 4x plus 7 equals 27, I have 4x plus y, and the directions are still solve for x. Well, we don't know what y is, but we know it's being added to 4x, so I just follow, the same steps. I'm going to subtract y from both sides. Now we can't do 27 minus y because they're not like terms, so I just do 4x equals the expression 27 minus y. And then to get x alone now, I'm going to divide everything by 4. And so what I do is I get an expression for x. X is equal to 27 minus y over 4. And the only way to get a numerical answer there would be as if I knew what x or y actually was. All I'm looking for is the expression that x is going to equal. Let's look at D. So same thing, we're trying to isolate x. We follow the same steps, right? Except now the 4 has been turned into an m. So I start by subtracting y again, and I get that m times x is equal to 27 minus y. And then to get x alone, we divide everything by m. M divided by m on the left cancels out, and we're left with the expression that x is equal to 27 minus y over m. And that would be the answer to a question like this. Now the next one, same problem again, except now I've replaced the 27 with a p. So it's the same process still. If the directions say solve for x, we're trying to get x alone. We subtract y from both sides. We get that mx equals p minus y, and then we divide everything by m, and we get that x is equal to p minus y over m. So what we just did here is we are solving equations called literal equations. And literal equations are equations where you're trying to isolate a variable and you have a bunch of other variables in the equation. It's used a lot when you are using formulas in geometry and that sort of stuff. Being able to move your variables around will help you when you're solving equations with some kind of formula. So let's take a look at a few more. So what we have here are letter E again, except now I'm saying I want you to solve for m, not x. So whenever you're doing problems like this, what you want to do is you want to locate the variable you're trying to isolate, and you undo the operations that are being done to m. So again, because this is m times x plus y equals p, you have to get rid of plus y first. You have to subtract y. So it's the last operation being done to m. It's the first thing that you undo. So you get mx equals p minus y, and now because I'm trying to get m alone, I divide everything by x. And I get here that m is equal to p minus y over x. And there's my answer to that one. All right, now the next one. This one is now saying, okay, solve for y. Well, let's look at what's happening with y. Y is being added to mx. Not multiplied, it's being added. So mx is, we have to cancel out that entire term. Think of it as like you have 1 mx. We're going to subtract mx here. Because let's see if I was collecting variables, like if it was 4x or 3x or something, I would subtract it, right? So let's take the mx from one side of the equation to the other side by subtracting it. Now, if again, think about this. Let's suppose that was like 1 mx minus 1 mx. That cancels out because they're like terms. The mx's will equal the same thing. So when you subtract them, they cancel out to give you 0. So you're left with y is equal to p minus mx. And that is your answer. So let's continue for a few more. I encourage you, if you think that you know what the right answer is, I encourage you to stop the video and try it and see if you get the right answer. But I am going to go through and explain each of these because they're all a little bit different. So number 1, solve for f. So I'm going to just like locate. There's the f. That's the thing I'm trying to get alone. When you're trying to think about what to cancel out first, you're usually canceling out the thing that's furthest away from the 3f, right, from f, which is 4g. So what I'm going to do is I'm going to subtract 4g from both sides. And it's kind of like collecting our variables, because if you notice, I have a 6g on the other side. So we take away 4g because we're trying to get rid of the entire term. If you're trying to get rid of an entire term, you're going to be adding or subtracting it. So then I'm left with 3f is equal to, well, 6g minus 4g is actually 2g. Because they're like terms, we want to combine them. Then to get f alone, f is being multiplied by 3, so to cancel out multiplication of 3, we divide by 3. And so my answer here is going to be that f is equal to 2g over 3. And we're done. All right, number 2. Same problem, except now I'm saying let's solve for g. Well, we kind of have a problem here because I've got g here and g here. When you've got the variable you're trying to get alone in 2 places, you have to figure out how to get it in 1 place. The way to do that would be collecting our variables to one side of the equal sign. So the first step is the same as what we just did on the problem before. We subtract 4g from both sides, which leaves us with 3f is equal to 2g. And now we've got g in one spot. We're trying to get that guy alone. Well, that guy is being multiplied by 2. So to undo multiplication by 2, we divide everything by 2. And the 2's cancel out on the right-hand side, and you're left with 3f over 2 is equal to g, which is the same as saying g equals 3f over 2. And continuing now to number 3. Number 3 says we want to solve for b. So again, I'm going to locate the variable I'm trying to solve for. It's that b right there. There are no other b's in the problem. So to think about how to start this problem, we'll think about, well, what's happening to b? b is being multiplied by a and c, and then added to 2d. So the last thing being done to b is adding 2d. That's the thing you have to get rid of first. We want to move the entire 2d. So we're going to subtract 2d from both sides. These cancel out. You're left with a times b times c is equal to, well, 4d minus 2d, again, are like terms. So you combine them to get 2d. So now the next part is, again, we're trying to get this b alone. B is being multiplied by the a and the c, kind of at the same time. So you can divide out more than one thing if they're all on the same term. You want to do that. So what we're going to do now is we're going to divide not by just a, but by a, c. Divide both sides by a, c. And what that does is over here, a divided by a is 1, c divided by c is 1. So we're left now with just the b. And so what we get is b equals 2d over a, c. And that's your answer. Let's take a look at number 4. Number 4 is really simple. It says solve for m. Well, m is right there. And what's happening to m is being multiplied by c squared. So all I have to do is undo multiplication by dividing both sides by c squared. And you're done. So your answer is e over c squared equals m. And moving right along to number 5. Again, if you think you've got it, stop the video and try. So this one says solve for v squared. So I'm going to locate, the v squared. The v squared is here. And I'm going to undo all of the things being done to v squared in the opposite operation. So v squared is being multiplied by m, then divided by r. The last thing being done to v squared is divided by r, so that's the first thing we have to undo. The opposite of dividing by r is to multiply by r. So we're going to multiply both sides of this equation by r. On the right-hand side, the r's cancel out because they're like cross-canceling. Remember that r that we're multiplying by is kind of like r over 1. So then on the left-hand side, I'm left with r, little r, big F. It's a good idea to keep your variables. If they're lowercase, keep them lowercase. If they're uppercase, keep them uppercase, because these are formulas that often have a meaning. Okay, when I'm done with that, I'm left with RF equals m v squared. So now v squared is being multiplied by m. The opposite of multiplying by m is divide by m. So now I'm going to divide everything by m. So I get lowercase r, uppercase f over m equals v squared. And I'm done. I have isolated v squared. So these types of problems, it's really important to show your work every step as you go. All right, so number 6. Number 6, go ahead and put a little star by number 6 because these types of problems sometimes tend to throw people. It's asking you to solve for r. Now r is a divisor. R is the thing that you're dividing mv squared by. You cannot isolate r if it's in your denominator. So what you have to do to start this problem off is clear that fraction bar. Same thing we did in number 5. Even though I'm trying to get r by itself, if it's in the denominator, you can't get it by itself until you get it upstairs in the numerator. So I'm going to start by multiplying both sides by r. That way, it's not in my denominator anymore. So I'm going to have rf is equal to mv squared. So now the r, because it's being multiplied by f, to get r alone now, you divide everything by f. So it's kind of like the r and the f. They basically just traded places. So what you get is r is equal to mv squared over f. And so, moving right along. Number 7, notice again, we have the v that we're trying to get alone. Where is it? It's in the denominator. You can't isolate a variable if it's in the denominator, so you got to get it upstairs. So start this problem by multiplying everything by v. So what I have is v times 5d equals 10m. And the v's will cancel out on the right-hand side. So now to get v alone, well now v, if you notice right here, v is being multiplied by 5d. Well, the opposite of multiplying something by 5d is to divide it by 5d. So we divide both sides by 5d. And then the 5d's cancel out, and we're left with v equals, it may look like v is equal to 10m over 5d, but that's a fraction that can be reduced. 10 divided by 5 is 2. So we should reduce it. It would be 2m over d. And that's your answer. So let's take a look at number 8. Number 8, again, I would encourage you to stop the video, try it, and come back. There's a little weird thing that we're going to do in this problem at the very end. So you do definitely want to chime back in if you're trying it on your own. All right, so to get y alone now, notice the y is here, and it's being subtracted from 2x, then divided by 5. Since you've got that fraction bar, you have to multiply both sides by 5 first. So that's the last operation that was done to the y, so it's the first operation we undo to the y. So the 5's cancel out. What you're left with on the left-hand side is 5w is equal to 2x minus y. Now we're trying to get y alone. Well, I got to cancel out 2x. I'm going to subtract 2x from both sides. Subtract 2x. Cancels out on the right-hand side. 5w minus 2x can't be combined because they're not like terms, and they're subtracting. So we just have to write it as 5w minus 2x equals not just y, but negative y. Now it doesn't say solve for negative y, it says solve for y. So you kind of have to look at this like it's a negative 1y. To cancel out negative 1 times y, we're now going to divide everything by negative 1. Now, negative numbers are typically not left in our denominator, and it's negative 1. So think about it. You can divide each of these terms here, 5w by negative 1 and negative 2x by negative 1. You want to divide both of these actually by negative 1 because we don't want a negative number in our denominator. So what that does is gives me negative 5w plus 2x equals y. And there's your answer. Okay, so here are two problems that now have parentheses in them. So number 9 says solve for x. My x is inside the parentheses. Because my x is inside the parentheses, it's probably a good idea to get rid of the parentheses. So let's go ahead and distribute. So I'm going to distribute the 3 to the 2x and the 1. And when I do that, I'm going to get y equals 6x plus 3. And now we're trying to get the x alone. So let's subtract 3 from both sides. And we get y minus 3 is equal to 6x. And now to get x alone, I'm going to divide by 6. This entire thing has to be divided by 6. So my answer is y minus 3 over 6 is equal to x. Now you might ask, can I reduce the 3 and the 6? And the answer to that is no, because it is being subtracted from y first. So remember, you can't cancel things out between addition and subtraction signs, only if it was multiplication. All right, let's go ahead and take a look at number 10. Number 10 is, again, solve for x. And because x is inside those parentheses, I would say you kind of have to distribute. So let's go ahead and distribute the 3. So we're going to get 5y is equal to 3y minus 6x. And so now let's get that y alone. That x alone. We're trying to get x alone. And so you've got to cancel out that term of 3y first because it's the furthest thing from x. It's the last thing you would deal with. So we subtract 3y from both sides. And then again, over here, 5y minus 3y, well, those are like terms. So go ahead and combine them to give you 2y is equal to negative 6x. Now to get x alone, I've got to get rid of that negative 6. It's being multiplied by x, so I've got to divide everything by negative 6. And so these cancel out, and you're left with x equals, you should reduce this 2 over negative 6. That really just reduces to negative 1/3. And since you have a y over here, you could just make it negative y over 3. The negative sign should not stay in the denominator. It should pop out to the front or on the top. Okay, let's finish up the last two problems. The two problems that we just did had parentheses in it, and you had to distribute to be able to isolate the variable. That was the best method. Here are two examples where distributing is not going to help us. So let's just take a look at number 10 for a minute. Number 10 is saying solve for h. Now, you may have never seen anything like this, but this h, you would say this h sub 1, and this is h sub 2. This is a formula here that probably is some shape that has lots of different heights to it. This h is the one we're trying to isolate. So I'm going to put a little arrow above that h to keep in mind we're trying to isolate that h. H sub 1 and h sub 2 are basically different variables. That's not what we're trying to isolate. So you might be thinking, well, let's start by distributing the h. But if I distribute the h, then I'm going to have h times h sub 1 plus h times h sub 2. And then I'm going to have h in two different places. You don't want to have the variable you're trying to solve for in two different places. And then there's no real way to combine those because we don't know what h sub 1 and h sub 2 is. So this problem, we don't want to distribute. What we want to do to start with the problem is we would, first of all, clear that fraction bar. When you have fraction bars like this, that is the first thing that you're going to do, is get rid of the fraction bar. So we're going to get rid of that fraction bar by multiplying everything by 2. And so the 2's on the right-hand side will cancel out. On the left-hand side, I'll be left with 2a is equal to h. And then in parentheses, I'm going to have h sub 1 plus h sub 2. Now keep in mind, we're trying to get the h alone. So think about what's happening here. What's happening is h is being multiplied by this set of parentheses, right? The order of operations will tell us to do this first, then multiply by h. So since this is being multiplied by h, well, to undo it, we have to divide everything by h sub 1 plus h sub 2. And do that on the other side. H sub 1 plus h sub 2. And if you think about it, this and this will cancel out. Because it's being multiplied by the h, you're allowed to cancel things out. All right, so then your answer here is going to be 2a over h sub 1 plus h sub 2 equals h. And you're done. All right, let's take a look at the last one. So the last one says solve for c. Again, the c is on the outside of the parentheses right here. If I were to distribute it in, I'd be distributing it to two different places, and that's going to make the problem harder. So we're going to leave that c right where it is. We're going to clear this fraction bar by multiplying everything by 3. That cancels out. Then you're left with c times b plus 2d in parentheses equals, we'll go ahead and do 4 times 3 because you can, that's 12. And then to get the c alone, because c is being multiplied by this, we're going to divide everything by what's inside the parentheses, which is b plus 2d. And when I do that, the b plus 2d, these represent the same number. They're going to cancel out. So you're going to be left with c is equal to 12 over b plus 2d. All right, if you're confused about any of these, make sure that you ask for some help.